Okay, so sometimes we have to do what's called rationalizing the denominator. So let's say you have the square root of 3 over 5. Well, there's a rule that says you can't have a fraction under the radical sign. Okay, so you're like, okay, well, great, I'll just split it up. That's the square root of 3 over the square root of 5. And that's true. That's true. The problem is we don't know the square root of 5. It's not a perfect square. And so we can't have a radical sign or a square root sign in the denominator. So we have to get that denominator not to be an irrational number, but a rational number. That's why we say we're rationalizing the denominator. See, if you were to put this denominator, the square root of 5, in a calculator, it's just going to be an irrational number, a decimal that goes on and on and on and doesn't repeat. And so we have to get that number to be rational. Okay, so how could we get 5 to be a perfect square? Well, we could multiply by another 5. Now, I could multiply this by the square root of 5. Then I'd have the square root of 25. I'd have that situation where I had a squared and the square root of a squared, and that would work out great for me. Now, can I just multiply by the square root of 5 down there? Well, yes and no. I can multiply by the square root of 5 as long as I do it to the numerator as well. Okay? So, this is like a 1, and that's not changing the value then, because you could multiply by 1 and still get the square root of 3 over the square root of 5. So yeah, I'm allowed to do that. Just have to remember, whatever I multiply in the denominator, I also have to multiply in the numerator. So we're looking at trying to get that denominator to change to a rational number. Okay, now what happens if I do that multiplication? Well, we have another rule that says, okay, square root of 3 times the square root of 5, that's 15, the square root of 15. And then down in the denominator, you could write it as the square root of 25, but you already know what's going to happen, right? It's that situation that you created. You have the square root of 5 squared, so you know it's just going to be 5. Sometimes students like to write the square root of 25, but you don't have to because you already know what it's going to be. Now, notice that I have a radical in the numerator, that's okay, and now the denominator is not a square root, it's just an integer. And that's great because it's rational. So we have rationalized the denominator. Now this is the answer. So sometimes students are like, oh, but couldn't I cancel the 5 and the 15? No. If you're going to cancel, they have to either both be in the radical or both outside the radical. But if one's in and one's out, you can't cancel them. Okay? So I can show you what I mean by that. Like if I have the square root of 16 over the square root of 8, that I can do. I can cancel 8 into 16, and I can say that's the square root of 2, and I'll have to go through that whole rationalizing process here. But here, I cannot cancel. Okay, no canceling here. And I said if they were both outside. So like say you had something like 4 times the square root of 2 over 2. You could cancel that 2 into the 4. That you could do. But you couldn't cancel the 2 in the denominator with the 2 in the radical. That you couldn't do. Okay? All right. We'll do more of those, so don't panic if you're like, what's going on with all this? Okay. Try to find the smallest number that's going to make the denominator a perfect square. So up here, we chose to multiply by the square root of 5. Okay, so that was the smallest number. There are bigger numbers, but that was the smallest one. Okay, so they give us some examples. We want to rationalize the denominator. So I have a 15 in the numerator, and I have the square root of 6. Now, it might be helpful. You might be saying, well, I'll just multiply by the square root of 6. That's true, but you might want to think of it in terms of factors. 6 is 2 times 3. Now, the reason I say that is because we're trying to find the smallest number. So maybe there's, a number smaller. There isn't this time, okay? So I only have 1, 2, and I have 1, 3. So I couldn't even, simplify that. So I'm going to have to multiply by another 2 and another 3. Sometimes it just helps you to see visually, okay, what do I need to multiply by? Well, I need another 2 and another 3. Well, what is that? Well, that's 6, right? And that's kind of what we thought we were going to do anyway. So I'm going to have 15 times the square root of 6 over just 6. Now you can put 2 times 3 also, but okay, now, remember what I said a minute ago? Don't worry about it. Well, now we have to worry about it because 3 will go into 15 and it'll go into 6, and you can simplify that. So let me pull out the orange pen here. 3 goes into 6 2 times, and 3 goes into 15 5 times. So my final answer here is going to be 5 square root 6 over 2. Okay, remember, if they're both outside the radical, you can cancel. If they're both inside, you can cancel. But if one's in and one's out, you can't. All right. So now let's look at this problem B. Well, we have the 8, right? So we've got a 12 up here. And then we've got 8. Well, if I want to think about that, if I could think about it as 4 times 2. I can take the square root of 4. The problem is I have that leftover 2. So what I really want to multiply by is another 2. Then I'd have enough 2's, right? So, you can write this all kinds of ways. But in the numerator, I'd have 12 times the square root of 2. And then in the denominator, I'm going to have the square root of 4, which is 2. And then I'm going to have a pair of 2's there, so I'm going to have another 2. Or if you didn't like doing it that way, you could say, well, what's 4 times 2 times 2? 16. And then what's the square root of 16? 4, which is what we're going to get. So many ways you could do it. I'm not sure which way works best for you. That's why you have to practice with the homework. You have to find what works best for you. Okay, now 4 goes into 12 3 times. So my answer is going to be 3 times the square root of 2. Sometimes you can cancel, sometimes you can't. Both these cases we could, but you can't always.